Hi everybody, welcome back. This video is about what OpenENV actually puts on your disk, how the workspace it creates is structured, and how to create a new project inside that workspace correctly. If you have the Erlangen example running from the setup video previously, this is the next step. By the end of this one, you will have a new empty project in the right place, wired to the vanes and INET installation OpenENV provided, and ready to build your own scenario into. So first, let's start in the workspace folder OpenENV created with init. In the previous video, I named my workspace vanet-workspace. Yours might be vanes. Just remember what you wrote in the previous one. So if we go into this workspace and we list out what's in there, you can see that we have INET 4.6, OMNeT++ 6.3, and vanes 5.3.1. So these three directories are the siblings at the top level. That's the full resolution from the one OpenENV install that we did in the previous video. INET comes along because vanes uses it for some of its channel and mobility models, even without the separate compatibility layer. There's no vanes INET folder here. That component only shows up for a different install combination, one that specifically pairs vanes with INET's full networking stack for scenarios where vehicles need to run INET's IP stack directly, not just borrow its channel models. So if we wanted to, we can confirm what's actually wired together by doing OpenENV info vanes latest. So this prints out the resolved dependency graph so you can see why INET is here without guessing from the folder name alone. So let's enter our workspace. In order to enter the workspace, we have to do our op_env shell. And that initializes our shell, and then we open up OMNeT++. So the IDE opens to the point where we pointed our workspace at. We already have our INET and vanes here, and they're visible in our Project Explorer, and the recent OMNeT++ version auto imports on launch. If it's not imported, as I showed in the previous video, we can go into the existing projects and point it at the vanet workspace. So now this is where you create your project. So now we're going to create our project. So we're just going to do a new OMNeT++ project. And we're going to name it Vanet Scenarios. We're going to keep the use default location checked because it's already resolves to the siblings of INET 4.6 and vanes 5.3.1, but you can always double check what the path is here just to make sure. I also like to have an empty project with the source and simulation folders. This way that we have our C++ modules go into the source and the network definitions and run configs go into simulations. Now, right-click the project, go to your properties, and go to project references and make sure INET and vanes are checked. Then we can apply and close. Now we want to test the NED wiring before we go any further. So the next thing that we would do is we go into our source folder and let's just make a new file. And what we're going to do here is we import this. Now, we see here we actually have one thing, which is that the declared package does not meet. And that's fine because we have a package that is declared here as vanet scenarios. We put that package in and import. All errors are resolved. That is good. That's a clean resolution, no red underline, and that confirms our project references are correct. If it's red, you need to build vanes first, right click it, build the project, and do the release configuration. The NED index does not populate until vanes builds at least once. It did build in our previous video when we ran our sample. Now we can delete this test file. Project references only resolves our NED types. the C++ compiler needs its own include path into vanes, which is a separate setting. So we need to go back into our properties and go to our OMNeT Makemake section. We select the source folder, and then we click Options. We do the Compile tab, and we make sure to click Add Include Paths Exported from Reference Projects. This will now help us compiling for C++. This is a step people skip, and it's the single most common build failure at this early stage. The NED import resolves clean. The C++ header isn't found. This is where your problem is. So now that we have set up this project to work, let's prove that the whole chain works before we go into building any more elaborate simulations. So what we want to do is generate a road network. So we'll go back to our terminal. So go back to our terminal here, and inside the OpenENV shell, we need to now navigate to our simulations folder of the new project that we made. And what we're going to do is run a net generate command. And it's going to create a file called simple.net.xml, and this is the road network itself. For this, in this case, we're using SUMO as net generate, which already a path inside the OpenENV shell. And this is so we don't have to handwrite our XML. This will give you a minimal grid with 2 intersections and enough road for a couple of vehicles to move on. So we run this command, and now this file has been created in our simulations folder. So let's go look at that. All right, so this is the network that was generated by SUMO. Now we need to have our root file. So I've already created this. It's a simple root XML. This has 3 separate things in it. We have our V-type that describes the type of vehicle, the acceleration, brakes, how fast it can go in a physical profile, and just not a specific car in itself, because vehicle types could be something else. In this case, it is a car. That's what we're making it. You could make it something else. Then we have the route, and that is the path through the network, named edges strung together in order. These named edges came from this generated file. Then we have our 2 vehicles. This says when a specific car enters the simulation. For example, the first one enters at 0, the second one enters at 5. That's 5 seconds after the first. So they're not driving together. Then we have our SUMO config. This is SUMO's own run configuration. It just points to the 2 files above that we went through, the network and then the route. SUMO reads this to know which road network and which vehicles to use. There is nothing here that is vane specific. That is our launched D. So this is for the vanes launch D, not SUMO. When OMNeT++ starts a simulation, it tells the launch daemon which files to stage into a temporary directory before starting SUMO. Each of these copies brings the files along. The last one here for the type config tells the daemon that that's the file that to actually launch SUMO with. Every file here has to be bare with no folder path, since the daemon refuses anything with a slash. There are also 2 supporting files from vanes itself that are needed. That is the config XML, and this was copied directly from our vanes folder, except I removed our shadow because I do not have any obstacles here. So this came directly from the examples here, vanes, and then we have our config. I do not have simple obstacles. That was what was deleted. And then the other one is the antennas. These 2 files describe the physical radio layer. So config XML sets the propagation model, how the signal strength fades with distance, and the decider, and how the receiver decides whether a message came through cleanly. Antenna XML, which is here, describes the antenna's radiation pattern. Neither of these is something you write yourself. They're the same files for every vanes example uses, so it makes sense to reuse them rather than reinvent radio physics. So now let's go into the app layer. So we're going to actually look at the code we are writing. First thing we're going to do is look at our header file. This is pingapp.header. This is the header. It's the declaration of what the ping app can do without the actual behavior yet. It extends our demo base app layer. That's vane's base class for anything running on top of a car. 3 methods are overridden here. We have the initialize. This is runs once when the model starts. Then we have our handle self message. The module sends to itself, which is how you schedule something to happen later. And then finally, the on WSM runs whenever the vehicle receives a message from another vehicle. We look at our pingapp.ned. The NED describes the model's shape to OMNeT++, its type, and its position in the simulation separately from the C++ code that implements it. This line right here at class pingapp, that's the part that's easy to miss. Without it, this NED type quietly inherits the parent's class binding instead of using your own. And OMNeT++ tries to initiate then demo base app layer directly, which was never meant to run on its own. All right, the meat of this code. This is the actual code. This is the pingapp C++ file. This is where our actual behavior lives. So, define module. This registers the class with OMNeT++, so it can actually be created at runtime. The missing piece from the NED file alone. Then we have our initialize. This calls the parent setup first, and since demo base app layer has its own initialization, it needs to run. So that's what's being initialized next. And then it schedules a self message 2 seconds in. That self message is just a timer. Nothing gets sent yet. Then we have our next function. This is handle self message. This is what fires when the timer goes off. It builds a base 1609, which is a basic vanes wireless message, fills it with the populate WSM, and that's a helper the base class already provides, and then it sends it out over the radio with the send down. Finally, on WSM is what runs on whichever vehicle receives that message. Right now, it just logs a line. But this is the hook you extend for anything that you want to make more interesting later. So now that this has all been set up, let's go to the network. That's back in our simulations. So this is the ping network NED. And all it does right now is extends scenario. Scenario is vane's own base network, and it already contains everything shared infrastructure needs. That's the connection manager, the obstacle handling, the tracing manager. Extending it with an empty body means you're not adding anything of your own at this level. So there's no car submodule here on purpose. Cars aren't declared in this file at all. They get created automatically at runtime as SUMO reports them. So with that being said, let's look at our INI file. This is our file that's going to be used to define everything for our simulation. So we have general, that's the block contains the simulation itself, not the network. We also then say network equals ping network. That picks up which NED file to run. And then we also have a sim time limit. It caps how long it runs. We have playground size, which coordinates space to the vehicles within. So this is our launch config here. This is telling which XML file to use for the launch. These are our NEC settings to configure the wireless radio itself, its transmit power, the bit rate, the propagation, and decider models pulled from the config XML. And the antenna pattern is pulled, so that's pulled from our config XML, and the antenna pattern is pulled from our antenna XML. This is the physical layer every message actually has to pass through. The app layer block picks up our ping app as the module every vehicle runs. Send beacons is set to false, And that matters here since this version doesn't use Vane's own periodic beacon system at all. Every message that gets sent comes from the schedule at call inside the ping app itself, not from the framework mechanism. The mobility block here sets each vehicle's starting position before SUMO takes over and starts reporting real positions through Tracy. So now we're going to run our Vanes launch D. So now we're listening on port 999, and let's run this simulation. So we can see that our playground has been set up. This is everything that we need. If we hit run, very quick. We've got our 2 nodes, they're sending messages, and simulation is done. You see up here, our custom code here received a message at and the timestamp. So that is the OMNeT workspace layout, your stack with OMNeT, INET, Vanes. They live together in one workspace, already at the versions that you need, and your new projects that go inside as folders, how you install the components with the project references in order to tell the IDE how to build the system and how they connect. If you like this, please subscribe to my channel. Feel free to leave comments if there's anything that you're struggling with vanet simulations. These videos do not come out as frequently as my other videos, but when you ask for something, I do make time to make them. So I'm more than happy to make these videos for something that maybe you're stuck on, that just lives inside my head because I've been making these simulations for a long time. With that, see you in the next one.